from measure assigned to each feature. The make route event layer is sort of the opposite of the locate features along routes. You can use it to take a table with already known measure values and plot features along the route lines. Any type of table supported by Esri will work. So if you have an Excel table with the unique route ID and measure or two from measures in separate columns, you can use this tool to create a layer called an event layer where each feature is placed at its measure or measures along the line. Like I mentioned back at the start, linear referencing theory and maintaining an LRS system can get really complex. I'd like to go over the Create Routes tool briefly, just to walk through some of the basic functionality and considerations. When you open the Create Routes tool, these are the parameters you'll have available. The first three are required parameters, and when you first open the tool, they'll have red asterisks next to them. The first and most important input is the line features, so the feature class or shapefile to be made into linear referencing routes. Maybe you have a centerline file for all the city streets or a mapping of all underground gas lines. This input can theoretically be any GIS line feature you have that you'd like to add linear referencing functionality to. This tool will enable M values on the input line features, even if this hasn't been specified prior to running it through the tool. The one particular requirement the line features need to have is actually the second parameter, route identifier field. This is a set attribute field of unique identifier values for each line. If you have multi-part line features with the same ID, meaning lines that start and end and pick up again elsewhere, but are part of the same feature, these will work. The M domain will pick up regardless of gaps. Basically, each feature needs its own unique ID to identify the route by in a linear referencing feature class. The third required parameter is a location to output the route features. This output can either be a geodatabase feature class or a shapefile, but because of how feature classes handle XY tolerance, basically snapping to vertex, it's generally a better practice to use a feature class. However, if there's a particular reason you need a shapefile, linear referencing functionality is possible there too. So down to the optional parameters. There are three choices for how the measures or M domain is set for your routes. The first is simply to use the length of each line. So if the line is 10 units long, the M domain will start at 0 on one end of the line and end at 10 on the other end of the line. Choosing this method takes into account the coordinate priority parameter. Basically, the minimum bounding rectangle around the features is used, and the selected corner is to use to determine which end of the lines gets the 0 and which gets the 10. So which direction the linear measure value is accumulated in. Alternatively, if you set your input line features to have a from measure field, you can use the values from a single method or single field method. This will start each M domain with the from measure specified in the field. So instead of starting the M domain at measure 0, it will start at the value specified in the selected measure field. In the example here, the single measure field is set to 5, so that route feature will start at 5 and end at 15, even though the line length is 10 units. This method, like the length of feature method, also relies on the coordinate priority to tell it which end of the line to start accumulating measure values from. You'll have to choose a corner using the rectangular extent of the features to determine which end starts with a specified set of from measures. The third method of setting linear referencing measures in the Create Routes tool is to use two sets of specified measure values, a from measure and a to measure. In this example, the from measure is 0 and the to measure is 15. This route feature will start at 0 but end at 15, even though the line is 10 units long. This method does not use the coordinate priority parameter, instead using the specified to and from measures and the digitized direction of the input line to determine which direction measures accumulate in. The last few parameters are the same across all three methods. So we're just looking down here at measure factor and measure offset. So the measure factor allows for the input route units to be multiplied by a particular value. So if you'd like to convert your units, such as from feet to miles, This multiplier parameter makes that possible. The measure offset field allows for an offset to be applied to all root M domains. Similar in concept to starting the domains with values from a single field, but as a blanket modification rather than being specific to each root feature. Very last, there's an option to build an attribute index, which ArcGIS uses to quickly locate records matching a query. It's probably better to keep the box checked unless you have a specific reason not to. And finally, hitting run will generate your linear referencing root feature class according to the parameters you specified. Once you have a set of roots through the create roots process, there are a number of things you can do with it using other tools in the linear referencing toolbox. For example, you can use the calibrate roots tool to recalculate the root measures using a point feature layer. The basic inputs are fairly straightforward. The input route features are your root lines, and the root identifier field is the attribute field with unique route identifier. The input point features are the third parameter, and they'll need an attribute field with a numeric measure value assigned to each point. These are the measures that will be used to calibrate the points. There are a number of different optional parameters. A measure calculation method, there's a search radius if your calibration points aren't right on top of the root line, and a bunch of binary options dealing with how the calibration interpolates, extrapolates, handles gaps, and so on. I don't want to get into the weeds on these today, but each of them handles specifically the calibration points effect on the root lines a little bit differently. And you can toggle these just depending on the specific needs of your linear referencing system. So the graphics here show an example of how calibrating roots might work. So starting with your 10-unit root line and setting calibration points at 0, 2, 8, and 10, running the calibrate roots tool sets those points to the M values specified by each calibration point. So basically, 0 becomes 1, 2 becomes 3, 8 becomes 7, 10 stays at 10 because that's what we specified. And so to examine the result on the right there, the line now starts at 1 instead of 0, and 2 is interpolated between 3 and 1. 10 remains the same, but 7 is now at the unit length 8, according to the line length. And then the values between each of those calibrations have been interpolated. So another useful function available using linear referencing routes is the locate features along routes tool, which is used to assign measures to existing GIS features. Essentially, the tool uses a set of route lines, finds GIS points, lines, or polygons within a certain distance of each route, and outputs them into a table. This table can then be used as a reference list or joined back to the original GIS features to integrate them into the data. The first parameter for this tool is the input features to be located. These can be any points, lines, or polygons you'd like to assign measure values to. The second parameter, input root features, are where your root lines go. And the root identifier field, again, is for the unique root field in its attribute table. So getting down to search radius, this allows you to set a distance from the route lines that the tool will look for your input points, lines, or polygons. The default is 0 unknown units, and if you run it this way, it will find features that are basically right on top of a root line. So alternatively, if you want to find points, lines, or polygons within a distance of each route, so say 100 feet on either side of a highway, this parameter allows you to do this. The next few parameters deal with the output event table. The output location, root identifier field, event type, and measure field are all set there. And then there are 5 yes/no checkbox parameters at the bottom. So having keep only the closest root location checked means that only the closest route to the point, line, or polygon feature will be retained, even if multiple routes are within its search radius. Include distance field on output table will include an offset value, positive or negative, depending on which side of the route it occurs on. Keep zero length line events deals with how polygon features might be handled. If to from is specified, it's possible that the length will be 0, and this parameter allows you to choose if you want to retain or discard these zero length events. Include all fields from input, just includes any attributes from the input in the output table. If you just want a simple list of features with measures and offsets, but not any of the rest of the attribution from the input features, you could uncheck that box. Finally, use M direction offsetting will decide whether to use the M accumulation direction or digitized direction to decide left and right. Feature offsets to the left of root lines are considered positive, and those on the right are considered negative, so they'll get a minus sign in front of their offset to distinguish them. The graphic here illustrates an example of the locate features along routes functionality. Again, here's the example 10-unit route with measures. In this example, 5-point locations are along the route on either side, and by running the tool, each point gets a measure assigned to it in the output table. The last tool we'll examine today is the Make Route Event layer. Like I mentioned earlier, in a way, it's the opposite of the Locate Features Along Routes tool. So if you have an existing table of records with known measures, you can use this tool to plot those records as features along the route lines. And these features are called events. Again, the first input are the route features and unique identifier. The input event table can be any kind of Esri supported table type. This includes Microsoft Excel tables, as long as you have fields for unique route IDs and measures set. The next few parameters allow you to specify these fields in the input table: route identifier field, event type, pointer line, and the measure field, or to from measures if your events are going to be lines. Let's see, layer name or table view is the output layer, and offset field allows an offset from the center of the line to be set. This will place the lines on either side of the route line, depending on whether the value is positive or negative. Generate a field for locating errors is a really handy function when making a route event layer. It will add a field that tells you whether there is an issue plotting your points and lines along a route. For example, if a unique ID was wrong in the input table, or a measure was out of a route's M domain, the field will contain a message letting you know for each event feature. The events with a positive offset will be placed to the right of the routes option, reverses the default behavior for placing the events using the offset field. Instead of being placed on the left, positive values are placed on the right with the specified offset. And finally, there's an option.
The first route that is the closest to the pole, that's the one that's going to get assigned there. And again, we can run that, and the name finder will find its matches. And then if we click on one of these features here, we can see that the neighbor finder gives us a whole bunch of interesting stuff about the closest features. It's giving us the angle from the point to that line, what the closest candidate coordinate is, and also the information that we want here is the distance, which is the offset distance, and it's already added in here the NRFID, so that's great there. Now the neighbor finder actually doesn't really work very well with multi-line features. Name that, and so that's what we're going to be. So now what on one of these, hopefully if you want to have that ID of the route that